This is video lecture for week 11. Here we start chapter 4, integration, which is the last chapter for the course Calculus 1. Here we study antiderivatives and indefinite integrals. If capital F is antiderivative of small f, then the indefinite integral of small f with respect to x is equal to capital Fx plus c. This is the symbol of indefinite integral. Fx is integrand, dx is variable of integration and it is read as with respect to x, and this c is arbitrary constant, that is indefinite. Therefore Fx plus c is indefinite, that is it is known as indefinite integral. The process of computing an integral is called integration. Let's see some examples. Indefinite integral of 3x square dx. This 3x square is small f. We know that 3x square is a derivative of x cube. So this x cube is capital Fx. When 3x square is derivative of x cube, then x cube is antiderivative of 3x square. Opposite. Anti means opposite. So integration of small f, that is 3x square, is equal to capital Fx, that is x cube. Here the variable of integration is x. Here we have t. So we need to find the integration of t to the power 5. We know derivative of t to the power 6 is this. So we want only t5. So I cross multiply, we have this. So derivative of this is this. So therefore integration of this is 1 by 6 t to the power 6. Means for every differentiation rule we have corresponding integration rule. So we know the power rule for derivative. Derivative of x to the power r is rx r minus 1. This is the derivative rule. So that is the power rule for the derivative. So we have a power rule for the integration. That is the integration of x to the power r is x to the power r plus 1 by r plus 1 plus c. So note that r should not be minus 1. If it is minus 1, then the denominator is 0, then it is not defined. Let's use this power rule in example 1.4. R is 17, so 17 plus 1, 17 plus 1, answer. Here x to the power 3 is in the denominator, so first we need to bring it up. It becomes minus 3, then r is minus 3, so minus 3 plus 1, minus 3 plus 1, we have answer. We have some fractional exponents, x power 1 by 2, 1 by 2 plus 1, 1 by 2 plus 1. X to the power 1 by 3, bring it up, it's minus 1 by 3, r is minus 1 by 3, minus 1 by 3 plus 1, minus 1 by 3 plus 1. These are the formulas of integration, and they are all corresponding to derivatives formulas. This is the linear combination of the function with the number, and when you are finding the integration of this, the number comes out. So AB are the numbers here. So number comes out of the integration and you integrate only the function. For example, here we have a equal to 3, fx is cos x, b is equal to 4, gx is x to the power 8. So we take the number out and then we integrate only the function. So integration of cos, sine, integration of x to the power 8, power rule this. Here we have a plus, minus, no change. So 3 out, 2 out, integration of e raised to x, e raised to x. This integration of this is tan inverse x. We have this form. Derivative of 1 by x, derivative of ln x is 1 by x. So therefore integration of 1 by x is ln x plus c. We have used this formula in finding the logarithmic derivative, that is derivative of ln of fx using the chain rule, derivative of ln 1 by fx, derivative of f prime. So it is this. So when the derivative of this is this, then the integration of this is this. So therefore integration of f prime x by fx dx is ln of f. So note that numerator is derivative of the denominator, then the answer is ln of denominator. You see here we have x square tan x. What is the derivative of tan x? X square. So this is f prime, this is f. Therefore ln of f, that is denominator, plus c answer. Here are some examples where in this the first case power is 2 by 3, bring it up, minus 2 by 3, use the power law, you have answer. In this case the numerator is 2x, find the derivative of x square plus 1, you get 2x, therefore ln of denominator. In this case we have a single term in the denominator, therefore numerator terms can be divided here with each x. So x cube by x is x square, 1 by x, so x to the power minus 1. See, we have this. Since the power is minus 1, don't use the power rule, you use the other rule, that is ln of x. In this case you just multiply these two, you get x square minus 1, then integrate x square, x cube by 3 minus integration of 1 x. Whereas in case of b and f, there are no corresponding derivative formula, therefore you can't find the integration of these two. So there are many functions for which there are no integration, but for every function you can find the derivatives. Here is another example where you are given the second derivative, that is y double prime t, which is acceleration, and you are asked to find the position function y of t. So these values are given: y prime 0 equal to minus 100, y of 0 is equal to this. These are to find the constant of integration c. So since the second derivative is given, so if I integrate the second derivative, I will get the first derivative. So I integrate this, I get this. You have a plus c. So this c we find using this condition. So this is t and this is y prime. So note that this is nothing but the velocity itself. So we can write y prime t as v of t. Say, substitute. So that is t equal to 0 and y prime is minus 100. I substituted. Then I get c equal to minus 100. Put it here in the velocity or y prime t. We have this is the velocity. Now I need a position function, therefore I will integrate this again. See, integration of y prime, I get the position function yt. So this I will take and then I integrate. Again I have constant of integration which is unknown. To find this I will use this second condition. So t equal to 0, y equal to this. So we substitute and get the solve it, you get this. Finally the position function is the same, the function here, and the c value you got it we have here. So these are the examples of what you call here. These are the examples here for finding the general antiderivative, that is indefinite integral. And here we are given the first derivative, so you need to do the integration once. In these cases you are given two derivatives, so you have to integrate two times. So in this examples 45 to 48, leave this 49. So in this again your velocity is given, find the position function, that means find integrate once. Here you integrate once, here you integrate twice because acceleration is given, here you integrate twice because acceleration is given, and these conditions you are using to find the constant of integration. So these are the answers for what to call the examples, and what we studied in this video lecture. What do you mean by antiderivatives? What do you mean by indefinite integral? And how we find indefinite integral? That's the end of the video lecture number for week 11. Thank you.